Right, year 11 methods. Let's talk about inverse functions. The inverse of a function is found by taking all the ordered pairs of that function and switching the xy coordinates around. So what I've got here on the screen, some notes I made up earlier, are exactly that. So taking a function of x, it's the inverse notation is f minus 1x. That's the inverse function of x. And so I've just taken the example here of a function of x equal to a quarter x, and just taken some ordered pairs from that function. So just a few select ordered pairs, 0, 0, 2, a half, 4, 1. Just check that they fit this function here. They satisfy that function definition. And then we're just what we're doing here is for those 4 points switching the xy coordinates. They're changing places. So the 0, 0 obviously doesn't look any different over there. The 2 half becomes half 2. 4, 1 becomes 1, 4. Minus 4, minus 1 becomes minus 1, minus 4. So the definition of an inverse function is a switch in xy coordinates from an original function, whatever that might be. So let's go ahead and see what the effect of that is. The x values here make up the domain of the original function of x. But look over here, they become the range of the inverse function. Okay, stands to reason that the range of the original function, because they now become the x coordinate in the inverse function, to become the domain of the inverse function. So the domain and range are interchanged naturally as a consequence of the xy coordinates swapping their positions around. Now, what I've done here now is I've drawn these two functions. The black line is the function f of x equals 1 quarter x, and you'll recognise that as being going through the origin, gradient a quarter, but it's the points that we plotted here, 0, 0, 2, a half, 4, 1. You can see those points coming out there. And then you can also see the points that they map to. So 4, 1, we interchange the xy positions there. That becomes 1, 4, and that point is there. So you can see here that is reflected in this purple line here, y equals x. So 4, 1 reflected in y equals x becomes 1, 4. And if we do that to every point on this black line, we end up with the red line, which is the graph of the inverse function of x, which has equation y equals 4x. We can see that from we can see that by having a look at the gradient of the red line, which is 1 across and 4 up. So the gradient's 4, it goes through the origin, so y equals 4x. But we might algebraically need to be able to find inverse functions, and so we'll just go through those steps now using the example f of x equals a quarter x, or sometimes it might look like y equals a quarter x. If it doesn't, make it y equals a quarter x. So the first step is to replace your f of x notation with y equals. Make it y equals a quarter x. Then the second step's the important one, switching x and y around. So that's the interchange process. That's the key step in. From this point on, from step 2 onwards, we're now dealing with the inverse function, having done this xy swap. So, and that's noted here in my notes, f of x becomes f minus 1x here. So steps 3 and 4 are just about rearranging this equation that has had its xy interchanged. So we started with y equals a quarter x, we change the y becomes an x, the x becomes a y, and now we make y the subject, which is achieved by multiplying both sides by 4. So y equals 4x, and the last step is just to replace y with the inverse function notation, f minus 1 x equals 4x. So, and that's the equation of the red line. Okay, so xy interchange, domain of the function becomes the range of the inverse function. The range of the original function becomes the domain of the inverse function. They are reflections of each other in the line y equals x. That's the graphical view. The algebraic view is this 4-step process here. And I'm going to get you to do exercise 6G in class tomorrow, and do the work requirements from that, please. But I've just done a couple of examples here from question 1 just to get the ball rolling. It's on page 186 if you'd like to have a look at that. The requirement there is to, with a function defined across all reals, it's a linear function, find the inverse function for this. So we go through the steps. We make f of x turn f of x into y, so it's y equals 6 minus 2x. That's step 1. Step 2 is interchange. Y becomes x, x becomes y. That's step 2. Step 3 is make y the subject. So we're taking 2 steps over 3. There they are there. And that's step 3. And step 4 is to then rewrite y in inverse function notation, f minus 1x equals that. The domain and range are all real. The domain and the range of the original were all real, so there's no changes there. Looking at question 1f, which is the function defined across the domain 0 to infinity, so just the positive values of x of f of x equals x squared. We go through the steps algebraically. Step 1, replace f of x with y. Step 2, y becomes x, x becomes y. That's step 2. Step 3 is make y the subject. That's done there, plus or minus root x. Step 4, write it in inverse notation. Now we know that so this is the inverse of y equals x squared. We now need to attend to the domain and range. The domain of the original function is all positive values. So the range, you can see I've underlined it there, the domain of the original function, 0 to infinity. The range of the inverse function, therefore, is 0 to infinity. So only values above the y-axis. Now if we had a look at f minus inverse function, what graphing plus or minus square root x, that's a sideways parabola. That's 2 branches. It actually isn't a function. But our range is only this branch here, because our domain, if you think about that domain there for y equals x squared, it is only considering values greater than 0 for x. So it's only the half branch of y equals x squared, the positive x branch of that curve. So the inverse function is just the positive branch of y equals square root of x. The domain of the inverse is the range of the original. Our range of the original was all positive values. So the domain is all positive values for the inverse function here. Okay, hopefully that helps with inverse functions. Quite an important concept. Please ask for help either through the teacher you have in class tomorrow, or by emailing me. I'll be checking my emails whilst I'm away, so feel free to get in touch. All right, see you later. Best.